Hi, this is section 9.1. Gosh, this is going quick. We only have 3 chapters left and we're done. 9, 10, and 11. So, time flies when you're having fun, huh? Well, this is my kind of fun. Maybe it's not yours, so I shouldn't say that. All right, well, this is our radical chapter. Not that it's radical in that way. It's radical because we are going to be using radical signs. All right. So a radical sign looks like that. Let's talk about it. Okay. The thing underneath the radical sign is called the radicand. Okay. This is your radical sign. And the reason we don't say it's a square root is because it might not be. Okay, so the number that sits inside this little crick right here is called the index. All right, index. Now, if there is no number in there, what is it? Well, it's a 2. All right, and that would be a square root. Right, that's a square root of 49, but we can put other numbers in there. We can put the 4th root of 16 in there. We can put the cube root of 125. So it depends. These are all radicals. This is specifically a square root, a cube root, and a 4th root. All right? Okay, so what are we looking for? What is this asking us to do? Well, it's shorthand notation for give me a number multiplied by itself 2 times, because there's a 2 in here, that's going to give me 49. All right? Give me a number multiplied by itself 3 times, that's going to give me 125. Or give me a number multiplied by itself 4 times, that's going to give me 16. All right, now we know that the square root of 49 is equal to 7, right? We can verify that through our calculator. But that's not the correct answer. Why not? Well, because this is called the principal root. Oh, would that be principal or principal? I don't remember which one that is. The principal root. Okay, so it's always the positive value. All right, but think about it. If I multiplied 7 by itself twice, do I get 49? Absolutely I do. But what about negative 7? That also equals 49. So really, the square root of 49 is equal to plus or minus 7, right? The positive and the negative here. So now when we do evaluations, this is an evaluation. This is just saying evaluate this radical, okay? Then we usually just do the positive value, the principal root. But if I would set something equal to something else, you know, if I would have the cube root of x is equal to blah, 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 then I want to take both the positive and the negatives. All right? I want to look at both values when I solve. So here, look at the word. You have to, these are not hard, but you just have to look at the wording on these. When it says all square roots, it's looking for both this and the negative. So it's looking for both of these answers here. Okay, and we're supposed to use a comma to separate our answers, so we'll do 7 comma negative 7 with no spaces in between. All right. All square roots of 16/9. Well, each one of these can be broken down, right? 16/9. We can split this. Square root of 16 is 4. Square root of 9 is 3. And we want both positive and negative values of that. Okay, so you want 2 answers that look like that. Okay, so you want a 4/3 and you want a negative 4/3. Fantastic. Now here it says the square root. Okay, what they're looking for here is the principal root. So just you have to really, especially on a test, you have to be very, very careful about what it's asking you because you don't want to get these wrong. You know, this is so easy that you don't want to get it wrong. You don't want to put in the positive and the negative 11. You want to just put in the positive 11. So, okay? So just be careful on those. Those are tricky in the fact that it's all in the wording of the directions. So, okay, so I'm going to leave you alone on these, on that one. Find the square root of a negative 9. What's going on there? How can I have a number multiplied by itself that's going to give me a negative? Well, I can't, right? Because 3 times 3 gives me the positive 9, and the negative 3 times negative 3 gives me a positive 9. So I can never get to that negative. I can in my imaginary arena, in my complex number system I can. Certainly, this is 3i, all right? But in the real number system, I can't. Okay, so this is not a real number because it's got a negative in there. And because I have a positive, not a positive, an even index, all right? My index is 2. So if I would have a 2, 4, 6, 8, blah, 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 I can't do that. If I have a 3, 5, 7, then I can. So it's odd, even stuff. All right. Find the square of the radical expression. Okay, you have to read these directions really carefully. What does that mean? Well, it means you're squaring this. 361 squared. Okay? Whenever this matches this, when these two things match here, they wipe each other out. So the square root of a square is itself. So for instance, this is x, or this is x. Okay, so the square root of a square is itself, and the cube root of a cube is itself, and so on. Okay, so this is just equal to 361. It's kind of like multiplying by 2 and then dividing by 2. You just get back to where you were. These are called inverses of each other. Okay, so that's the inverse of a square is a square root, and vice versa. Okay, so you have to be very careful about the wording in here. Find the square. Right? If I square all of this, I just get the radicand back. Find the square root. Principal. Positive. No negative. All right? Here we can round to the nearest thousandth. Square root of 5 is not a perfect square, so we don't know what that is. So we would say it's 2.236. All right? So we can use our calculator for it. These are going to go really quick. All right. Again, we have a even index. I can't take the even root of a negative number and have it be real. So this is not a real number. Okay. This is gonna go really quick. What about the cube root? Well, we can use our calculator. I'm looking for what number multiplied by itself 3 times will give me 512. Sometimes I don't know these, so I'm going to use my calculator. Here's option number 4 here is my cube root. And then I can just plunk the number in there. It's 8. Okay. Well done. This section's going to go really quick. Well, what about a negative with an odd index? Well, that one actually does work. Why is that? Well, because I'm looking for what number multiplied by itself 3 times will give me a negative. Well, that's a negative 3. Right? Because these two make a positive 9. And then this one times this one gives me the negative 27. So do you see how every pair of negatives will wipe each other out, but then you've got the odd one that's always going to make it negative? So this one does work. And you can also use your calculator. Your calculator will tell you that. You can put a negative in here, negative 27. You get a negative 3. Now what happens when I do a even index with a negative, negative 49? It's going to say, oh, not real. It's a non-real answer. Okay? So your calculator can help you. All right, what's the difference between this one and that one? Well, look at where the negative sign is. The negative sign is underneath the radical on that one. and it's outside the radical on that one. So this is saying, let's go back to 12. This is saying what number multiplied by itself 3 times will give me a negative 27. And this is saying find the number multiplied by itself 5 times will give me this, and then take the opposite sign. Okay, so you want to kind of disregard that, and you can think of it this way too. You can think of it as a negative 1 times the 5th root of 1024. Remember, a negative is just shorthand for negative 1. So we'll find the 5th root first. Okay, so you're going to hit a number 5. You have to put the index in, and then we want the xth root here. It's a number 5. We haven't done this in a while. Then we want to put in the number 1024. So it's 4. So this piece right here is 4. So we can say that we have negative 1 times 4, which is negative 4. So this is indicating take the opposite sign of whatever you get there. Okay? So we're going to put in a negative 4. We're going to check that. Good job. This is so easy, I think. The 4th root of 1, what number multiplied by itself 4 times will give you a 1. That's 1. 1 times 1 times 1 times 1. And I'm going to leave you alone. Some of these are, this is not a real number, right? We have an even index. We have a negative under the radical sign. All right, so the square root of a square, we're back to this stuff, right? The square root of 16 squared. Well, these two things match again, right? That and that. They wipe each other out. They're inverses of each other, so all we have left is a 16. Okay? But this one's a little different. Because if I was to take, like, okay, here, if I put a negative 2 in here, it's going to tell me I'm wrong. And why is that? Because I just told you that it's whatever it is underneath there. It's the radicand. But really a negative 2 can be broken apart like this. Minus 1 to the 20th power and a 2 to the 20th power. Okay? And that can be broken apart this way. Each one is individual. Each one can get its own radical sign to the 20th. All right? This piece right here, well, what's going on? If I take a negative 1 multiplied by itself 20 times, anything that's an even power, I have a positive 1. Okay, so let's just verify that. So if I have a negative 1 and I raise it to a positive power, all those negatives wipe each other out because I've got pairs of them. I don't have that dangler left over. So that's a 1. Right? And the 20th root of 1 is 1. So this whole piece right in here is 1. 1 times anything's itself. So this is actually a 2 because this 20 matches that 20 and we've got the 2 left over. So this is actually a positive 2. All right? And that's because we have an even here and we have a negative down there. Then we have to separate our negative 1 out of there and say, well, that's really a positive 1. Same thing here. All right? We've got an even power. We've got a negative underneath there. So that would normally be a positive 8, right? But then we have this. It says take the opposite sign. So isn't that a negative 8? It sure is. Because we have 1 on the inside that's going to get wiped out, but then we also have 1 on the outside that isn't. Okay? All right, and then this last one, we're going to use our rule that x to the nm is equal to x to the nm. All right? These are identical. This is a rule that says if you have a radicand with a power and an index, you can also convert it over to an exponential. So my easiest way of doing this is to convert it over to an exponential. okay? 25 fifths, right? N over M. Well, 25 fifths is 5. So it's really just x to the 5th. Let's try that one, and then we're done. Boy, this went quick. Good job. All right, 15 minutes. That's not bad. I'll see you for section 9.2. Have a great day.